What person remembers cat theory? Well, two then. Right, it's otherwise known as Bowker's law. This is consistency, availability, and partition tolerance. This is how distributed systems for the last few years have been working together. So, consistent means you put the information in, you get the same out. So you put number 1 in, you get number 1 out. Number 2 in, you get 2 out. See what I mean? Consistent. Then it's available. It's kind of self-explanatory. If you want to look at your data, you can get your data. If it's not there, it's not available. And then there's this one, which is partition tolerance. What this actually means is it can survive network failure. So if you've got a cluster of machines, one of the machines disappears, it still can provide information. How I like to think of this is the network knows where the data is. You look at the database, it knows which machine to pull it from. So, cat theory. Oh yeah, just as a point, laser dot. There's a little greyish dot in the middle. That can't exist because of the way you have to build these things. I'm going to explain that. You have to have a pick-to philosophy. So you can be CA or AP. Sorry, you can be CP or AP. This is kind of like the uncertainty principle, Heisenberg's uncertainty principle. Who knows about that? Yeah, now I've got to explain it. So why is this important? There's a bit of a history lesson that goes with this. So back in the day, you'd have massive systems where they could be consistent and available. The reason for this is because they just put them on a giant box. Yeah, they had a giant box, so they didn't need to know where the data was because it was one box. So when the box got full, they just put more drives in, make it bigger, put more drives in, make it bigger, and eventually, okay, it's a really big machine. But then it came this entire idea of distributed systems and databases. So these things have got information on different machines. So it needs to be partition tolerant now because it needs to know where the hell to get the information from. Is that cool? Cool. That means you have to be partition tolerant and something else. You can't have a system where it's looking at multiple machines and go, that's consistent because the chances are that machine will have one set of information. The machine halfway over the world in Seattle will be different. You know, you can't register that every machine will have the exact same state at any time. So you can be either consistent and form right blocking where the system shuts down, writes to everything and then provides it you, or you can be available where information can be constantly grabbed from it. We call that. I'm getting no nods. Am I talking way too fast? Ah! Right, so the entire thing is a major set of design decisions. NoSQL databases came in with the production of commodity hardware. Cheaper hardware meant they could distribute the workload across loads of machines. With loads of machines means you need to know where all the information is. So if you've got machines in multiple locations, you can either shut the system down, write to everything, and bring it back up. That's consistent. Or you can write it to all of them and get different states of information. That means it's available, but you always get something. Now, from a database perspective, you kind of always want to get information. If you don't get your database information, you kind of don't have a database. It defeats the point. Is that cool? There we go. So, there is, just to be fair, this thing called NoSQL. It's out of a paper from Google called Google Spanner. Google Spanner is everybody here heard of Google BigQuery? Yeah, cool. Right. Spanner is essentially the transactionally secure version of Spanner, and it works. It uses some ridiculously complex algorithms to try and be more consistent. And to make it worse, it makes it even more expensive by integrating atomic clocks onto every machine to keep state. So that's like, However, if you want to play with NoSQL stuff, the only reasonable project at the moment is called CockroachDB. So if you want to go and play with a NoSQL, there you go, CockroachDB, that's for Google. Right, so we're very quickly going to go through some tags of database to prove the point that NoSQL is a load of geek. We're going to have key value, document DBs, column, and graphs. There are hundreds of other types, tabular, tuple. Insert here. There's this thing called multi-model as well. It's like a Swiss Army knife. Defeats the point of my talk if I'm giving you types and just wanted to do more of it. So I'm going to ignore that. So, yeah, as I said, completely skipping the multi-model ones. This also takes a bit of audience participation. I have an open heckle policy, so decide to throw up and verbally regurgitate words at me. First up, key value stores. Can anyone name any of these? Okay, if you want to play a little game, there's a URL you can get from the slides later where you can actually just play this yourself and play. Guess the name of the key value store. But That is a key value store. I only realised that a few months ago. I didn't actually realise it was a key value store. But here we go. Big fat list. So many of them, they carry on for about 5 lines down here. So there's a lot of them. And the whole idea is a key value store is, it's the same as a dictionary, a hash, an array in any programming language. You have a key, you have a value. You grab the key, you get the value. So why would you use a key value store? Key value stores are really simple, really powerful when used correctly. The best uses for them in large distributed systems nowadays are things like sessions. You can also use them for lazy queues and stuff. These things are just designed to drop things in and really fast grab them out. They're really, really powerful if you use them only for simple jobs. If you want to do anything more complex, you need something else, like a document DB. So, document database. Can anyone name any of these? Mongo. Any others? Actually, my personal favourite. So yeah, here's it once again. At the end, you can play a game of name the document database. The list of them is a lot smaller. However, there's still a bloody lot of them. A lot of proprietaries. I have to include that's Cloudant. That's the bit I specifically work with as part of IBM CDS. So all the t-shirts, etc. But then we've got loads of them. RethinkDB, which was somebody went, I like Mongo, I want to do it better. Here's RethinkDB. And then there's Document, which is like a real-time version. Oh, and here's one for you, PouchDB. Who here's a web developer? Right. Look up PouchDB. You'll start being able to build offline applications with it, so information stored in the browser as if it's a database. So what is a document DB? Traditionally, they're considered to be a subclass of key value store, as the primary lookup on them is the same thing. It's a key value store lookup. But they introduced a more complex search query, so using the metadata from the information you put into the value to create more indexes. So we've seen indexes. Somebody's rolled an elastic version at the back of it, so you can do complex ad hoc querying against these systems using indexed tables. So NoSQL has indexes. That's like an SQL database. So, why would you use a document DB? Primarily as your operational store. This thing, you're just storing your user information, your product information, all these large objects that you just want to keep together. It's pretty much that simple. Large objects with complex searches. Yeah, that's it. So, next up, column databases. Who wants to name one of them? Did you just say SQL Server? Yeah, that's not an NoSQL service. NoSQL Talk. Anyone name any of them? Okay, well here once again is the game. Play the guessing game. Can you name that NoSQL service? If you can't, here's a list of them. The list is a little bit smaller than all the others because they're a lot more specialised. So the biggest ones you guys have probably heard of are those two, Cassandra and HBase. Who's heard of those two things? Yeah, most of you. It's a column-based data store. What a column-based data store is, yes, you can put in whatever type of data you want in there, but it still stores it in a table-like structure. So it's more like an Excel spreadsheet. You can just have random pieces missing from your Excel spreadsheet, but it still is elastic in the fact that it'll introduce new fields and store them and index them as necessary. Things like Cassandra are fantastic because they also include vector timestamping, so it can do mildly auto-merging information by just getting timestamp difference. That's about the same as new information. Why would you use them? They are used a lot for operational stores. They're really good at this. Most of them have an amazing gossip communication layer between each one so that they keep each other up to date. They are fantastic at this stuff. They're also used for things like time series data sets. Because of the vector timestamps, it means the system is ridiculously good at indexing and sorting things based on time. It's actually something most systems find very difficult because of the whole fact that there is no kind of standard time format anywhere in the world. We'll all pick an ISO and go with it. So, why would you use it? Operational store, distributed systems, beautiful fault-tolerant things. Moving on to graphs, my personal favourite at the moment. Can anyone name a graph database? Neo4j, that's a good one. Any others? Okay, let's move on to the game bit. So, if you want to play the guessing, can you guess the database name game? There it is. So here's a list of them. Odd enough, there are more graph databases than there are column stores, even though column stores have existed for longer as a technology. Graphs existed for longer as a theory, but not as actual core databases. So there's Neo4j, Titan, Giraffe. There's also a project called Tinkerpop, which is this universal wrapping library thing around Neo4j and Titan primarily. Also works there on top of the more skip that bit because I don't have that much longer. But yeah. So, why would you use a graph? Well, what is a graph data store? Who knows their graph theory? At least one person remembers their graph theory. I had to relearn it all a couple of years ago. It's insane. Right, the entire thing there is it stores objects of information as nodes and stores the relationships between this information as edges. The power comes in the fact that you can move between nodes horizontally a lot and just keep moving backward and forward in cyclical patterns, exploding things with complex queries that go, well, it doesn't exist, let's hop back 3 steps and take a different route. So unlike your normal SQL service where you'll go join, finite result set, you can make the graph do really complex, weird things in the middle that kind of make you want to vomit when you watch them. So, yeah, it's all about the relationships between information. Unlike the other stores where the primary thing is the object and its metadata, a graph is, yes, it was the object and its metadata, but the important and really fantastic thing are those relationships joining the objects together. Why would you use a graph database? Because of the really complex hopping things. So the best use cases are recommendation engines or pattern detection for anti-pattern, so fraud, that sort of thing. Other things who here has heard of the 6 degrees of Kevin Bacon? Right, that's an example of something called the ERDOS number, which is the connection between individuals. It's the same as Facebook. How connected are you to everybody else? It's that simple. So social mapping the information and finding the relationships between one object and any other object in the system. Graph can do that so much better than any SQL service, because in SQL you have no idea how far away that relationship could be. If you try doing that, you pretty much knock over any SQL service, go join, very done. Right. So yeah, it's really complex things. You can upload those horrible SQL queries that you just watch your SQL server go, oh my god, is it going to fall over this time? Oh my god, is it going to fall over this time? Oh my god, no, it's not. It's in the graph service. Yay. So I'm kind of tired. I did that really, really fast. But let's party because, you learn some new things. What have we learned? NoSQL is a lie. Who agrees with me? Seriously, nobody here agrees with me. I'm offended. Seriously, nobody? Oh. Bring minutes. Excellent. So, do you understand why NoSQL evolved the way it did in a different format to how SQL servers did? To get a resounding no. And who here agrees with me is a different database for a different job? You can't use one to solve all of them. Excellent! Now I'll take that as a win. And for some reason you use different databases. I don't know, everybody should use Postgres. Respect the double claw, people. Pick the right tool for the right job. Because picking the wrong tool for the wrong job is just going to be dangerous. I'm just going to let this gift run. There we go. Always pick the right tool for the right job, because something can go horribly wrong. So, if you get the right tool for the right job, you'll get the right result. If you don't, you'll just be going nowhere. And we can all agree this is the end of an entertaining talk. So, that's Mike Elsmore. That's my talk. Questions? I'll apologise now, that was actually meant to be delivered in 30 minutes. I've shaved 10 minutes off by talking really fast. Cool. Questions?
So, why did you say that CouchDB is your personal favorite? Can you explain a bit?
Primarily because I got into using NoSQL because of building web applications. So there's that library I said, CouchDB. I found that first. So I was building web apps, front-end JavaScript work, and then went, okay, so everybody keeps telling me I can make CouchDB connect to CouchDB, and it just does replication. And it starts working, okay. Oh my god, Couch means I don't need to write a server when I'm writing really hacky bad apps. Okay, I like that. So yeah, I love CouchDB because of how dirty I can use it. Simple. It can do really, really, really complex querying with map reduce functions. That's great afterwards, but that's after the fact I've realized I can do dirty things fast. Anything else? Anybody else? Come on, people. I need more coffee. Yeah, like more coffee.
You said Facebook and GraphDB in one sentence. What does Facebook actually use?
Actually, the service Giraffe is an open source project out of Facebook. They no longer use that. They've rolled onto something else internal. No idea what it is. It's like LinkedIn. They have the best graph service on this planet, or they won't open source it. God damn them. I want to play with that. Could you imagine playing with LinkedIn and realizing I can get rid of all the recruiters? Does that answer the question? Sweet. Next. Or we can call it quits. I know. There's coffee out there's cake. What's cake? Who here is going to be seeing my talk later because I'm equally as energized for that? Well, at least one person. 2 people are going to watch me make this absolute mess of myself. Okay.
Cool, thanks.